Hi everybody, welcome to Barcelona and Mobile World Congress 2019. I'm Patrick Vanderwill, Chief Communications Officer of InterDigital. As you know, folks, I do a video like this every year to walk you through our booth and walk you through our demos, and it's always a pleasure to do it because we always have some fantastic stuff to show. Before we get to the demos, I just want to take you through some of the stuff you're seeing behind me here. What we do in Barcelona is we convert part of our booth to a sound stage, and here we host panel discussions, thought leadership panels on video topics, wireless topics. We also make the stage available to our media partners. So this year at the booth, we've got Telecom TV, Light Reading, the Mobile Network, and telecoms.com doing some interviews with some of the leading people in the world of wireless. Over to my right, we also got a very important part of Mobile World Congress. Is one of the great things about a show like this is it gives you the opportunity in the period of just a few days to meet with people from all over the world. The kind of meetings that normally you would take months of time and travel and expense to go get these meetings put together, we're able to get them done in 3 days at Mobile World Congress. Those two meeting rooms to my right are occupied 85% of the time that we're here. Wonderful value for the money. Over to my left, we've got the folks from Cordant, who are doing their 1M2M platform case studies. And it's a great study. I'm sure that you saw the announcement a couple of weeks ago that they were spinning out as a standalone company, and that's a very exciting thing. And then a further announcement was that they were signed on as the official platform provider for the Deutsche Telekom IoT Solutions Optimizer. So a wonderful win for them, and they're here demoing with us as well. Let me walk over to some of the demos. One of the themes this year at Mobile World Congress is InterDigital as a partner. There's a lot of companies that produce telecommunications equipment. There's a lot of companies that produce platforms and nodes and systems like that, but they produce them to sell them to customers. InterDigital is a little different because what we're interested in is research. And so when we provide a platform, when we develop a system, we develop it specifically so that research partners can easily hook into our systems, deploy them into their test beds. So over behind me, we've got a couple of demos. One is radio access test beds, where we provide radio access solutions to universities and public-private partnerships who want to test out their ideas. And then over to the right, we've got our core network test beds. So one of the most important aspects of 5G is not, is it going to make my phone faster? It will, but our phones are already plenty fast enough. One of the most exciting aspects of 5G is how is it going to transform the network? And that's what a lot of our demos here today are all about. Let me turn to Fred Schreider over here. Fred, I was just describing that our core network, our radio access test beds are kind of, I won't say custom design, it's the opposite of custom design. They're designed with the idea that anybody can use them.
Yeah, that's true. We're using open source in a lot of ways so that other researchers have access to the open source, and we're making, in this case, our platform open source for certain interfaces so that they can add their own special sauce on top of what we're doing.
And who are some of the people that we're working with?
Well, National Science Foundation has a project called POWER, Platform for Advanced Wireless Research. And InterDigital is a consortium member of POWER, so we have the obligation of providing in-kind contributions. Some of these examples you see here are 60 gigahertz backhaul and our NR 28 gigahertz phase array. These are both technologies that are going into those test beds. Now they just awarded those contracts late last year, and there's another 2 projects being awarded this year. So they're starting to get momentum, and you'll start to see this build out over the next couple of years.
You know what's exciting for us is some of the stuff that we were demonstrating as early as 2013, 2014 is rolling out into the market today. We see some companies that are deploying some direct-to-home millimeter wave systems to get 5G into your home. We were demonstrating those systems as early as 2013, so it's really a validating moment for us to see the market finally adopting the stuff that we've been demonstrating for years. And then we'll turn around and speak for a second with Dirk Trossen. I don't want to embarrass these guys, but I have to say one thing is last Investor Day, there was one slide in our deck that showed how every year since 2013, we have unveiled a world's first 5G technology of some sort or other. A lot of those innovations have come from this section here. the 5G radio access test beds, and the core network innovations that Dirk has led. Dirk, what are we looking at here?
What we're looking at is the idea of moving microservices as we can see them today coming up in 5G all the way down to the terminal. 5G at the moment is very much focused on improving the actual core of the network, but not the user plane, the radio access, or the terminals. We are demonstrating already how to apply the same principles that are currently happening in 5G all the way down to the terminal. And that brings benefits to the way services can be developed at the terminal. It brings new user interactions and user experience by disintegrating the services and bringing out new VR, AR experiences that we can show in a couple of years down the line.
So the advantage of pushing things out to the network edge would be things like lower latency, less demand on the core network, and also probably the use of cheaper equipment at the edge, correct?
Yes, I mean all of these. We already demonstrated about 2 years ago that we can use opportunistic multicast to reduce the actual utilization of the network. That means to reduce the cost of, for instance, AR and VR services. And what we demonstrate this year is, again, all the way down to the terminal, and that means you have 20 users watching the same stream. You have exactly one stream being sent to all of them. That makes these services, these future services, affordable and less costly. But also the new form factors you're talking about, it doesn't have to be your smartphone anymore. We redirect streams, for instance, to smart displays. We process them in the edge of the network, provided through site providers like hotels, and therefore it makes the demand for your particular, for instance, for the smartphone, very, very different.
Thanks a lot, Dirk. Dirk is part of our InterDigital Europe office, which is centered in London. Over the last 5 years, that's been a fantastic effort for us. They're involved in no less than 12 public-private partnerships and research consortiums, and just yielding an incredible amount of innovation for us. Thanks a lot, Dirk. Dirk was talking about the edge. Now, it's typical of InterDigital. A few years ago, when people were not even talking about 5G, we were showing some 5G systems. This year, everybody's showing 5G systems. So we're looking down the road 5 or 6 years, and a lot of what we're looking at is edge computing, edge connectivity, and transformation of the network at the edge. I'm going to come over to another demo right now that's really all about the edge. This is Charles Tuyagenda. He's with our InterDigital London office as well. And Charles is going to show us a couple of edge demos. Charles, what's the real advantage of edge computing? What problem are we trying to solve?
Okay, I can think of 3 key advantages of edge computing. The first is decreased latency, which in turn translates into a better quality of experience for the user. Another advantage is decreased cost of deployment. By incorporating the edge, we incorporate low-cost devices, and the overall solution would be cheaper in the long run. And edge also brings us much closer to the user, and by doing that, we're able to have a unified control and orchestration across all tiers of compute.
That's very interesting. So what are we looking at here?
Well, today we're looking at 2 edge demonstrations. One of them is a drone demonstration, which is all about collision detection and avoidance. And the second one is about the immersive 360 video streaming. So I will start with the...
Let's start with the drone, because this is a very interesting one. Bob Gazda here from our Conshohocken, Pennsylvania office.
That's right, good to be here.
So this is Bob's baby. And let me just preface it by saying, one of the biggest challenges in technology is you always develop the capability in advance of the application. So the question is, how do we develop an application that uses this new technology? And that's what you've come up with here, is an environment for coming up with new applications.
That's right, that's right. Should I hold this or no? Okay, so we have 2 things here. We have a mobile edge emulation platform. So this is a dynamic environment to allow an early edge developer to experiment with different network configurations, maybe before they're realized in the real world, to understand how his application can be deployed in the edge, do it back in an agile, iterative setting where he can get fast feedback. And then on top of this platform, we're deploying a drone traffic management system. So we have an edge detect and avoid application that's avoiding collision risks that happen at the edges of the network when drones are interacting with each other in a dense city environment. So if a drone is left just to be on its own, it may not be able to effectively mitigate all of its risks, like seeing around corners of buildings and things like that. So a drone can share its telemetry information with an edge service that's also gathering telemetry from other drones, maybe other sensors detecting obstacles, and better manage local airspace.
And where this becomes interesting is if you take away the word drones and you substitute in autonomous cars, you substitute in robots, you substitute in any kind of device that's looking for low latency and the ability to operate itself, this same application development environment is exactly what you're looking to use.
So you can see it with automobiles, same sort of collision risks almost directly apply, seen around corners. You can also imagine it in large cities, or not large cities, large factories, smart factory environments where more and more automation is taking place, especially with mobile robotics.
Thanks a lot, Bob. Let's go back to Charles for a second. So Charles, you've got a second demo about the Edge, correct?
Okay. Yes, the second demo about the Edge, as I mentioned before, is the live video streaming. Now, the benefits of this demonstration are fourfold. First, we've got a reduced cost of deployment because we decompose the entire video streaming service into several categories of compute devices from cloud, edge, and to fog. The second benefit is that we have reduced latency because we are running very close to the end user. Third benefit is we've got a unified control and orchestration, and this helps with operation and maintenance of the entire deployment. The final benefit is we've got reduced bandwidth because we only take the bandwidth, we only stream high definition video for the orientation that the user is looking at.
So just to give an idea of what we mean when we're talking about lower cost, simpler equipment, this is a demonstration that is showing very advanced telecommunications capability. The server is contained in that desk. The edge server is this computer.
Yes.
And this little router over here is what...
It's the NVIDIA Jetson. It's our fog node. It takes the It's the NVIDIA Jetson. It's the fog node, and it takes the orientation from the user. So once a user pans around to any direction, they feed this through an API to the NVIDIA Jetson, which then feeds that to the edge server, and which then retrieves the chunks of video either in high definition or low definition from our cloud, mini cloud server at the bottom.
And this, for those of you who follow our company's news, this is a rollout that was successfully tested in Taiwan as part of the 5G Coral Consortium, yet another consortium that we're a part of. Thank you very much, Charles. I'm going to turn here to the newest members of the family. They're not quite family yet. We just made an offer to acquire them. So they're cousins, I guess, because we've got a research arrangement, but we're hoping to bring them in as brothers and sisters. Technicolor are doing some of the most incredible work in video. And InterDigital, our goal, look, we've already built a strong position in wireless. We're typically ranked among the top 3 or 4 companies in terms of wireless standards essential patents. And the goal was, how could we build a business that is very similar to that, but in video, and do it quickly? We acquired the Technicolor licensing business last year. That was the first step of it. And then a couple of weeks ago, we announced that we'd made an offer to buy the research and development team as well. It is the best research and development team in the world when it comes to advanced video technologies. I'm going to turn to Valérie Allier, who's going to show us. This is very interesting. If the camera can just come in here and have a look. Don't touch the equipment, because then we'll spend an afternoon having to recalibrate it. But this is, what are we looking at?
In fact, here you are looking at a system, a capture system for creating volumetric video. In fact, what is volumetric video is a new way and new formats of video where you can experience sense of depth, sense of parallax. So you really feel like real video. And here, what you see here with this rig of camera, you see how we can acquire and create such content. So based on this setup, in fact, we are able to capture multi-view of one content. So I can sit here, just be acquired here by the system, and why here, with this system, I'm able here to view the 16 images captured by the rig, and out of that, our processing technology is able to create this volumetric video where I can move around my face based on the level of the degree of freedom provided by the rig. And here in the demonstration today, everybody can go, sit, get his picture, and then you can get this this content on your tablet, on your smartphone. So that's a way for everyone to experience what volumetric video is. And then here in the demonstration, you see here, there is a video because our system is not just for still pictures, it's video capture. So we capture video, and here the user can experience what is immersive video, where the system will follow the position of the user and create its own point of view. That's what we will see with this demonstration here.
Yeah, super. Thank you very much. Immersive video and immersive experiences is one of the most important areas of video development. Now, InterDigital, prior to our research arrangement with Technicolor, we were also doing our own research into the space, and so I'm going to come here and speak to June and Dong to talk about some of the immersive video that we've been doing. Now, the Technicolor folks are working on this problem purely for video. We're a wireless company, so we're looking at things a little bit differently, and the question we're trying to solve is how can an immersive experience like that be delivered with a minimum of bandwidth and really conserving the connection without overloading it. I think I've captured it, right, June?
Yes, that's right. For example, the immersive video, typically they have more than a couple of cameras. The bandwidth needed to transmit all the data to the client side is not possible with the current bandwidth. And with better quality, you need more cameras. To make it scalable, what we do is we do adaptive streaming. So the data going through the channel is what you need around you. So you generate a view from a couple of cameras around you and give you this one. You don't need all the data available all the time. So that's what we do is adaptive streaming. There are some other challenges, for example, latency and also processing power. So the latency means when you do streaming, to do the round trip, sometimes you will see when people move, you see the quality degradation for transition. What we solve that problem is that we try to set up some streaming strategy and use a smaller segment size to make sure the system reacts fast to people's change. And,
so to put it in really simple terms, to have a more immersive and interesting experience, you need more cameras. More cameras produces more data. More data clogs up the bandwidth, and it's more for the decoder at the end, whether it's a phone or a computer. It's more to try to figure out what makes sense. So your system, what it does, is instead of taking all that data and pushing it to the device, you have a system to select which data is relevant, get that to the device, which minimizes the bandwidth requirements, and it also minimizes the computing power at the end, correct?
Yes, exactly. So basically, we also have to make sure we do it in a smart way, try to mitigate some kind of inherent problem of streaming. So for example, the latency, you have to choose whatever you're streaming, how to minimize that effect over there.
Do you mind stepping into the box and showing people what we're talking about? I'll explain this a little bit. So June is looking at a scene, and the scene is using the camera above the computer to capture his facial position. And based on his facial position, it's establishing what views he needs and selecting them from the server and then transmitting those to the device. Now look at when June moves. He's going to move. The scene is going to move with him to provide the right angle of view. So what we've got here is a system where there's a certain number of views that have been loaded. And based on his position, the system is selecting which views are relevant to him and only providing those. Does that sound correct, June?
Yeah, that sounds very, very correct.
You're the engineer. I want to make sure we're right here. Thank you very much.
Thank you.
Let me move on to Dong Tian, because Dong Tian, a lot of this has to be focused on standards, because again, that's InterDigital's business model is very simple. Rather than sell solutions to customers, we contribute our solutions to the industry, and when the industry accepts our solutions, we then have to license those. And so it's a model that has served us very well. It's been really strong in wireless, and now we're trying to replicate that in video. So Dong, give investors and give folks at home a very 30,000-foot view of kind of how video standards works. I think people know how wireless standards works, but video is a new section for us.
Okay. Basically InterDigital has been working on video standards for many years. So roughly speaking, there's a big family of standards that related to video technology. And if we classify them roughly to 3 layers, the top layer would be the application standards, then system level standards, and compression level standards. At application layer standards, examples include like for TV, television, applications like DVB, ATSC standards. The other one example is 3GPP that handles the video application over the wireless network. At system level, there are 2 examples. One is how the protocol to deliver video content over network. That's the one example, MPEG-Dash. Another example is the file format that defines how video data is stored on the server. Okay, at the lowest level standards is the compression standard. The example here is the emerging standard that's called H.266 or MPEG VVC. Yeah, this is the lowest level that's to define the efficient way to represent video data in a very efficient,
So to put it in very simple terms, the application standards, those are the kind of standards that would be implemented, say, in a television set or in a streaming stick or something like that. And then when you go up to the system standards and the compression standards, that would be more like a YouTube or a Netflix, a video streaming provider, maybe your NBA app or something like that.
That's right. Yeah, that's correct. Exactly right. Yeah.
Okay, super. Thank you very much. I think we'll wrap it up here. It's been a great show so far. We're just getting started, but it's been a high traffic day. We've got obviously some really, really great demos, and we're really excited about the amount of traffic and interest that we're seeing here. Again, all of this is getting posted to our blog at www.interdigital.com. The landing page has a link to our live blog, and the live blog has links to the streaming sessions that we're doing, the panels that we're hosting, and also some thoughts that I've been sharing with our readership about how this show is going and what we're seeing here today. So make sure to check out the blog. Thank you for joining us today. Again, if you want to contact the company and have any questions about any of this technology, you can do one of 2 things. You can go to the Vault. The link to the Vault is on the homepage, and there you can do a keyword search and find any information you need about the demos that we've got here today. Secondly, my name, my phone number, and my email are on that page. By all means, reach out. Make sure you send me a note. If you have any questions, we can set up something either with myself or one of our experts. Thanks for joining us, and have a great Mobile World Congress.